Hi, welcome to the Chico Math Lab differential equation problem solving session. So today we're going to solve this problem, x plus 2y dx minus x dy here. Okay, so let's take a look with the initial condition y1 equal to 1. Okay, so for this ones here, there are several different ways you can solve the problem. In fact, when I first start, okay, so what I did here, and so I divided dx both sides, so x plus 2y, okay, minus x dy dx, okay, and equal to 0. So the first, I use the exact differential equations with the integration factor. I find the answer, but the process is very, very tedious. And then I was thinking about, well, can I rearrange this into a form I'm familiar with it? Okay, so then here, okay, so let's take a look. How do I rearrange it? Okay, so here now here let's take a look at x dy, right? So I want the dy to my right hand side, so I will have x dy dx, okay, is equal to x plus 2y. Okay, then I can do this x dy dx minus 2y equal to x. Then I can divide by x both sides here. So this will give me the dy dx minus 2xy, and it's equal to what? It's equal to 1. Wow, this turns out to be very beautiful. This is just a first order differential equation in the ordinary forms, right? Okay, so now I can do is I can try to find I can try to find the integration factors here. So I will do is the du dx is equal to negative 2x times u. All right, remember that if I find the first order ordinary differential equation, then I can just try to solving for u. Right? Okay, so I can solve for u here. Okay, so now in here you can do a separation. So you will have a du over u is equal to negative 2x over dx. And then what you do, you integrate both sides. Okay, so when I integrate both sides, I'm going to get the ln u is equal to, this is negative 2 ln x is equal to ln x squared, right? So I can get rid of that. So I know u is equal to x squared. So after that, the u is equal to x squared. What is the next step I can do? So remember, right? So we times the integration factor back to my equations here. All right. So this is my, this is my back to my equations here, dy dx minus 2xu. Right. So here, so I can substitute it back. I can multiply back to here. Okay. All right. So now let's see what happens here. So I will have a dy dx times x squared. Okay, so here, I'm sorry, here this is negative 2. I need to be careful. Yeah, so here is negative 2. So I'm sorry here. So this one going to be, you bring the negative 2 inside. So it's 1 over x squared. All right, so then the natural log. Okay, so here the u is equal to 1 over x squared. Okay, so 1 over x squared, then I can times the integration factor. So this is how we times the integration factor to my equations here. Okay, so I times 1 over x squared, okay, minus 2x times 1 over x squared y equal 1 over x squared. That's right, 1 over x squared. And then, okay, so here, remember that we said, okay, after I multiplied that, then these terms here, all right, so these terms become the derivative by using the product rule. So it will be 1 over x squared y. So if you use the product rule, you will get here, right? All right, so this is just a very typical step we did many times in our previous video. So this is 1 over x squared. Okay, so now integrate both sides. Integrate both sides, then the dx and the integrated disappear. So you will have x squared y is equal to negative 1 over x plus c. All right. So now I can times x squared both sides. So y is going to be equal to I times x squared here will be cx squared minus x, right? Then my initial condition is 1 equal to 1. So now 1 y equal to 1 and c the x squared, so it's c minus 1. So what is my c value? C is equal to 2. So this one's here, and this y is, we solved it, right? So it's 2x squared minus x. It's super easy if you rearrange that to a format, we recognize. Like I said, when I first did this problem, I did a hard way. I used the exact differentials methods here. I use mxy, nxy, and do the whole backyard. I got the same answer, but then it's very, very long and tedious. All right, so hope this will help you for your homework, and I guess I will talk to you in the next time. Okay, have fun and talk to you. Have a good day. Bye bye.